So I want to give you a couple more rules for taking the derivative. We have the product rule, which we found or showed just a little bit ago that it's not the same. If you have a function equals a product of two other functions, the derivative of the function is not the derivative of the first times the derivative of the second. So if we have two functions, f times g, they're both differentiable. Basically, we can take the derivative, they exist. Then the product is differentiable, and we can find the product, the derivative of the product, by looking at the derivative of the first times the second function, plus the first function times the derivative of the second. You may see rules, the same thing where you have f times g, the derivative of that product. You might see it as the first function times the derivative of the second, plus the derivative of the first function times the second function. These are identical. It's just the sum is in different order. So remember commutative property. If a plus b is the same thing as if we rewrote the sum as b plus c. And that commutative property holds here. And so those are equivalent. So it really just depends on the book or the text or where you're getting the information of how they would write that, but they're the same thing. And then we have the difference quotient. And the difference quotient is saying that if you have two functions, f and g, again, they both have to be differentiable functions. One other thing that we have to hold here is that g of x does not equal 0. Because it's undefined when our function in the denominator is 0 and not our numerator. Well, actually it's defined when they're both equal to 0. But anyways, the derivative exists, our denominator function doesn't equal 0, then the quotient is differentiable. And to find the derivative of a quotient, and this is, you have to be careful in the order here, order does matter. We look at the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator all over the denominator quantity squared. So you want to memorize those. I might make a flashcard and memorize those. That's going to make your life a lot easier. But let's look at an example of the product rule. And so it says find y equals x plus 1 all times the quantity squared of x plus 2, and we want to find dy dx. We want to find the derivative of y with respect to x. So if I didn't have that product rule, let's say use the product rule. If it doesn't tell you which rule to use, you can use which rule you want. You could distribute that and rewrite that. Let's first rewrite that because I noticed the square root of x. To you be able to use that general power rule, let's rewrite that so it doesn't have the radical. And so we can say y is equal to x plus 1 all times x raised to the 1/2 power. Square root of x is equivalent to x to 1/2 plus 2. Okay, so I'm going to write out the product rule before I even use the product rule. And so sometimes showing what you're doing or going to do is helpful in writing these steps out. Especially when we get into more complicated derivatives and we want to make sure that we didn't miss something. And so writing these steps out can be very helpful. So I wanted to find the derivative of y with respect to x. So I would write that as dy dx. The product rule says take the derivative of the first. So to write that, I'm going to take the derivative of the first d dx of my first function, which is this x plus 1. Then times my second function. So this times my second function, which is x to the 1/2 plus 2, plus my first function, which was this x plus 1. Then it says times the derivative. So I can write that as d dx of the second function. And our second function was x to the 1/2 plus 2. So this is what we're going to do. And now let's go through and take the derivative of each piece that we're supposed to. So taking the derivative of x plus 1. Well, derivative of x is 1. and the derivative of 1 is 0. So the derivative of x plus 1 is just 1 times our second function, x to the 1/2 plus 2, plus our first function, x plus 1. But the derivative of our second function using our general power rule, so derivative of x to the 1/2, let's bring our power down front, 1/2 x, and let's subtract 1 from that exponent of 1/2. So I'm going to write that 1 as 2/2. Plus the derivative of 2, but the derivative of constant is 0. So let's clean it up a little bit. Well, 1 times anything is just that anything. So we can drop that parentheses, and this is x to the 1/2 plus 2 plus, before I distribute, let's rewrite this 1/2 x to the 1/2 minus 1 power. So that is x plus 1 all times 1/2, and this would be x raised to the 1/2 minus 2/2 is a negative 1/2 power. So let's distribute this to each piece in that quantity x plus 1. So let's bring down what we haven't done or aren't doing, bring everything down. So bringing down x to the 1/2 plus 2 plus now distributing. So x times x to the negative 1/2 power. So this is where we're using, again, rules of exponent. Same base, you add your exponents. And so here, we're going to have this 1/2, and we're going to have this x times x to the negative 1/2 power. And I distribute that. So this is x to the 1 minus 1/2 power. Common denominator, so 2/2 minus 1/2. This gives me x to the 1/2. Okay, so distributing right here, that gave me plus my fraction 1/2, and x times x to the negative 1/2 we just saw was x to the 1/2. And now distributing that term to the 1, we would get 1 times that, so that's plus 1/2 x to the negative 1/2. So notice I can maybe clean this up a little bit. Notice that these are like terms. Same variable raised to the same exponent. So we could add the numbers in front. Unfortunately, this is a fraction. So I can think of my 1 in front of this first term, x to the 1/2, as 2/2. So I can add those two terms together now. So 2/2 x to the 1/2 plus 1/2 x to the 1/2. Well, 2/2 plus 1/2 is 3/2 x to the 1/2 plus 2. And recall negative exponents in the numerator. We can make this positive by bringing it down to the denominator. So that would give us plus 1/2 x to the 1/2 power. So I would clean this up a little bit. Oops. And x to the 1/2 power, we could rewrite as a radical. So this is 3 square root of x all over 2 plus 2 plus 1/2. X to the 1/2 power is the square root of x. So this is what we get our derivative function is. We should be able to rewrite that as a single fraction. And if we wanted to do that, just to get some review, we would have to look at the least common denominator of all the terms in there. So those 2 we can think of as over 1. So I notice my LCD, I need a 2 in my denominator, and I need a square root of x. So my least common denominator is equal to 2 root x. So I need a 2 root x in each denominator. And so I'm going to multiply by that fancy one to get that 2 root x in my denominator. So that first piece, let's rewrite it, dy dx is equal to 3 square roots of x over 2. So I'm missing the square root of x in this denominator. So I'm going to multiply top and bottom by the square root of x to get that least common denominator. Plus I had this 2 over 1. Well, I'm missing 2 root x in the denominator. So to get that, I'm going to multiply top and bottom by 2 square roots of x. And then I have this 1 over plus 1 over 2 square roots of x. So we've manipulated it so we have the common denominator. And we know that denominator that's common is 2 square root of x. So let's multiply 3 root x times the square root of x. Well, square root of x times square root of x is square root of x quantity squared, which is just x. So 3 square roots of x times square root of x is 3x, plus 2 times 2 root x is 4 root x, plus 1. So those are the same thing. One is just written as a single fraction, and one is written as a sum of multiple fractions. You could have approached this differently, but it told us to use the product rule. You could have approached this first by distributing both of those binomials and then using just the general power rule to find the derivative. Okay, so now let's go through an example where we need to use the product rule. And so we're given that g of x is equal to, our numerator is x squared plus 7x minus 2, and that's all over the following, and our denominator is x squared minus 2. And we want to find the derivative of this function. And so to find the derivative of this function, and I have the rule right here, let's go through and just write out the rule of what we're going to be doing with each piece. And so the derivative of g of x, this is equal to the derivative of our numerator. So I'm going to write that out as d dx of my numerator. My numerator is x squared plus 7x minus 2 times my denominator times g. Well, my denominator in this case is x squared minus 2 minus my numerator. My numerator was x squared plus 7x minus 2 times that derivative of the denominator. So times, I can write that as d dx of x squared minus 2 all over this denominator quantity squared. So x squared minus 2 is my denominator, and that quantity has to be squared. So now we're going to go through and take the derivative of which piece we need to. And so for this first piece, the derivative of our numerator. So the derivative, just using our general power rule of x squared, is just 2x. Plus the derivative of 7x is 7. Derivative of a constant is 0. So the derivative of our numerator is 2x plus 7 times our denominator, x squared minus 2, minus my numerator, which is x squared plus 7x minus 2, times the derivative of the denominator. So derivative of the first term in the denominator, x squared, is 2x. And the derivative of negative 2, derivative of a constant, is 0. All over this denominator, x squared minus 2 quantity squared. Okay, so we can clean this up by distributing in our numerator and combining like terms. You need to be careful, and this is where a lot of times students will mess up, is this minus sign right here. we need to be careful because that negative sign is going to be distributed. And I would first distribute this piece and then I would distribute it to every term. So we need to keep brackets or parentheses there when we do that multiple. So looking at our numerator, let's distribute 2x plus 7 all times x squared minus 2. So 2x times x squared, that gives me 2x cubed. 2x times negative 2, that gives me minus 4x. Now let's distribute the 7. 7 times x squared, so that's plus 7x squared. And 7 times negative 2 is minus 14. Minus, I'm going to put brackets here because I'm going to have to distribute this negative. So let's distribute 2x to each term in here. So 2x times x squared is 2x cubed. 2x times 7x gives me plus 14x squared. And 2x times negative 2 is minus 4x. All over the denominator, x minus 2 quantity squared. So let's distribute this negative to each term inside the bracket. And so doing that, we get the derivative. Bring pieces down that we haven't done, 2x cubed minus 4x or done anything with, plus 7x squared minus 14. Now distributing this negative to each term, we get minus 2x cubed minus 14x squared plus 4x all over the denominator squared. X minus 2 or x squared minus 2 quantity squared. So almost there, combine like terms in our numerator. So notice, let's look at all the cubes. I have a 2x cubed minus a 2x cubed, those cancel. Let's look at our squares. I have a 7x squared minus a 14x squared. So that's a negative 7x squared. Looking at all the terms with just an x, I have a negative 4x plus a 4x. I notice those cancel. And then the last thing I'm left up here with is the negative 14 all over x squared minus 2 quantity squared. So I notice that in my numerator, notice both terms have a negative 7 in common. And if I pull out a negative 7 from both of those terms, I'm left with x squared plus 2 all over x squared minus 2 quantity squared. If those parentheses, what were inside the parentheses, were the same, we could cancel the one on top with one of the ones on the bottom, but they're not the same. And I was just factoring just to make sure that they were not the same. So I could have left it like this up here. So we use the quotient rule to take the derivative of g of x there.